Hello, I'm Alia Belkaid, PhD in Architectural Sciences from Carthage University.
Hello, I'm Ines Hassoumi, PhD in Computer Science from University of Tunis.
Our co-author is Abdelkader Ben Saci from Grenoble University. Here we work at human-computer interaction for open rules optimization. Faced with the complexity of manual management of urban rules in architecture and urban design, this paper offers a collaborative and digital human-computer approach. It presents a generative model of authorizing bounding volume, called here ABV, which makes the best use target values of urban rules, its constraints optimization problem. In response of this challenge, firstly, we start with multi-agent approach for ABV generation. It will be followed by the optimization of authorizing bounding volume. Then we develop the human-machine interaction. Finally, we will present the results of an experiment. Actually, urban rules occupy a crucial place in architectural design. Many buildings have proved this. In New York, several building forms are described by Reem Koolhaas as generated forms, such as Fairturn Building. The Prada Building in Japan, Tokyo, also complies with urban rules and up, updates the principle of take zoning as a design guideline. That's why this paper presents an ABV generative model which uses the multi-agent system. It offers an intelligent system of urban morphology. It's able to transform the urban rules on a given plot into a morphological delimitation. The solution to this constraint optimization problem is an optimal constructible volume. So, how to generate an authorizing bounding volume based on the resolution of distributed constraint optimization problems. Second question, how does human-machine interactive work to respect urban rules?
The generative ABV model borrows concepts from genetic algorithm. It begins with initialization of parameters to generate a set of volumes. The generation step is followed by the evaluation of constraints satisfaction using the fitness function. It gives a score to generated volumes. For each situation assisted by the designer, the generative ABV model goes through a phase of selection and then classification of volumes to choose the optimal solution. This process is iterative until the optimum volume is reached. The first three steps represent the construction approach. The last two steps need human-computer interaction. The ABV generative model is detailed here. The choice of internal constraints or external constraints depends on the solution search situation. If the solution is unique, the system shoots down without the designer's intervention by simply taking a build approach. If the solution is multiple, the system asks the designer to find a desired solution. In this case, the designer dynamically influences the existing multi-agent system to direct its overall behavior towards a desired behavior. This approach is based on the topical and disturbance relevance of the designer.
For example, the designer here is an adjuvant agent which helps to achieve the overall objective of the system with topical relevance. The system asks the designer to choose a preferred implementation position for the definition of topical relevance. This agent makes it possible to promote closed volumes and eliminate the rest of the volumes in order to seek to reduce the number of volume offered. Another example where the designer is an opposing agent, it defines a disturbance relevance by parametric initialization table. At an advanced stage in the evolution of the multi-agent system and realizing that the machine is unable to achieve an optional solution alone, the system requires the arbitration of the designer by the modification of the parametric initialization table. The opposing agent will change the constraint weighting coefficients according to relevance to help the system to converge on a desired solution.
For the experiment, we choose case where the designer is acting as the opposing agent. We obtain 9 volumes with different values of constraint satisfaction. The system then classifies all volumes according to their performance. It's possible to formulate several types of relevance during human-machine collaboration. The volumes generated are compared only with a given relevance. We have presented in this work an ABV generative model for decision support system. So the urban rule can become a source of invention. Although the modeling is limited here to the generation of volume from urban constraints, the approach could be extended to other types of constraints, such as visibility, ventilation, sound sources of different cities in the world. Thank you for your attention.